Okay, does anybody know how the number pi was developed?
Someone got hungry.
There's some weird stuff happening with circles.
Something funny with circles, some weird person just pooped, right?
Divided by a
What's the decimal approximation there?
3.141592.
My brother knows.
And on
Okay,
it
go
goes.
for it.
I've never bothered to memorize more than that. I wouldn't bother with it if I were you.
Today.
How did we come up with that number?
You put an
Circumference
I to the
divided by-
calculator.
Circumference divided by
Putting an I to the calculator.
Pretty sure they didn't have calculators back then.
I'm pretty
And
sure.
this is not like back then when I was a kid, this is like back then, like ancient times.
Suckers. Guessing how it is you.
What is the circumference of a circle?
Minor two.
No, that's area. Right, that's what we use now.
It does work.
Here's how pi was developed.
I told you.
There was some calculus involved here, okay? But basically, they inlaid polygons inside the circle and made the polygon as many sides as possible, so they calculated the circumference as accurately as possible. They knew the diameter, they could measure it. And the more accurate they were with that, the closer and closer they got to pi. So they developed it by measuring the circumference and the diameter and dividing, right? And we get this decimal. Of course, they had to do everything longhand. Little pain in the tush. But they came up with pi. Do you remember what an irrational number is? I don't like it because I don't understand it.
It's not rational.
It's not,
Thinking American.
that's very deep. Non-repeating, non-terminating decimal, right? Okay, so. All right, so this kind of gives you an idea of where we're headed with the number E. E is also an irrational number. It's very special. And it didn't come about until the 1600s. So, grab your calculators. You have a calculator?
No idea.
No idea.
Ultimate, okay, for like 50 years, they didn't call this the number E, but they were kind of getting an idea that it was a special number. A really smart guy named Joseph Bernoulli eventually came up with something. Does that look familiar from yesterday?
Yes.
Compounded interest, right? Well, it turns out if you want to do continuously compounded interest, it throws a wrench in the works. Because this was our formula yesterday, right? Principal times 1 plus R over N NT. This would be compounded interest. N was the number of compounds per year, right? So if it was every day, I'd put 365. What do I put there if it's continuous? Nice guess, though. You would want to say infinity, right? What was that number? No, so continuously compounded interest causes issues with our formula, so we need a different one. So Joseph Bernoulli, the smart man that he is, started playing with things. And he tried this out. Okay. It turns out that if you put 10 in there. Okay, we'll just do a few calculations here. 1 plus 1 over 10 to the 10th. And give me a number. What is it? 3 point? Oh, 2, okay, good. Hang on, right? No, it's not. Let's try 100. And somebody else give me the answer.
2.7048.
Put 1,000 in there. Somebody else. There we go. We can't out the bag on that one. Okay, what about 10,000? There's a point to this, don't worry. Is that it? What's the next one? Does it look like we're, see how this big increase and then the smaller increase, does it look like we're kind of getting somewhere?
Yeah.
That we might be going toward a certain number?
Uh-huh.
What about 100,000? This will be the last one. None of you. $2.6. It turns out that as you go farther and farther, you head towards what we're calling the number E. E is the number that we need for continuously compounded interest. And I'll show you that formula here in a second. Approximately 2.71828. And you go on forever because it is an irrational number. Notice how this one goes to 4 decimal places, right? So it's a special number. Here's our special number to 10,000 decimal places. Holy cow, right? There is no pattern in that. It's non-repeating and non-terminating. Okay, so 10,000 decimals is a very small approximation when it comes to the infinite. But there are 10,000 digits of E. You can do the same thing with pi, right? Yeah, I bet so.
Yeah, someone's put.
They've actually had supercomputers compute pi as far as possible, and they still haven't got to the end of it. We're talking billions, trillions, quintillions of digits. Like craziness. Anyway, so pi and E have a special relationship there. Okay. So
Something don't have people at.
for continuously compounded interest. Your ending amount is, the formula is E in it. Use the same notation as the book. Amount is principal times E to the RT. A little easier than the last one yesterday. Perfect. Yes, very fashionable. This is our most fashionable formula. And remember what I said yesterday? If you can find an account with continuously compounded interest, that's the way to go. I mean, it might be pennies, more if you have $1,000 in the bank, but it will build. Okay, it will build, especially if you continue contributing to that. I don't care if it's $1 a week, put something in your savings account every week. All right? In some way or shape or form. All right. Let's just do a calculation here. Let's see, at $10,000. Should we use the measly rates we're getting right now or a better one? A better one. 5% is a pretty good rate of return. It beats inflation. It's not too far out there, it could be unexpected. And how much time? Over 6 years? Notice that these are both in years, okay, make sure those match. All right. And now what's your final amount? You just plug and chug. That should be it.
13,488.
Ooh, that's pretty good. That's just sitting there. You keep adding to that, it'd be a lot more. So, like I said, the Fed has interest rates hovering at 0.25% right now, so banks are only giving us, as savers, 0.05, 0.1%. Pretty awful. So, if you know somewhere that's better to put your cash as an investment, I would do it right now. 'Cause it's just sitting there. It's actually losing value because of inflation. So cash in the bank right now, bad deal. All right, so there's your compounded interest continuously. It involves the number E. Okay. You can also, okay, there are a couple other examples. Our standard exponential growth or decay formula with E in it. That's the standard. So if we took our compounded interest, the start value would be principal, K would be our R, the rate. Okay, this is the standard formula. It gets specific when you apply it to certain population studies or finance or whatever. So, you can also graph it. It doesn't change from the last couple days. The shape of the graph or anything, it just changes how fast it goes up. Remember, that's like saying this. Those are basically, this is an approximation, but those are basically equivalent statements. So what's the lighter set? X is 0, that to the 0, and go. I'm just going to kind of sketch it out. This number is on your calculators. There are two places it occurs, actually. You hit the second button and divide. Okay, that's E, just the number. And if you hit the second button and LN, it's on the left side. That gives you an e to the exponent, which we use a lot. I actually use that button more often. So you can do divide. Whoops, and you get e. Or you can do ln. We'll learn what that button is in the next couple days. And it gives you e to an exponent. Right? So you can say e to the fifth is that. If you want to graph it, oh, you can see that we were playing with e yesterday in calc. Little funky functions here, but they're calculator friendly, so we make it easy. And you can graph e to the x. So ways you can use your calculator with e. Okay. How would I make that a decay function? Yeah. You have a negative exponent. Right, so it would be something like that. That would make it an exponential decay. Because remember, that's 1 over. So there, I'm just sketching. There you go. There's a medicine question in here. A lot of drugs, pesticides, anything you get in your body chemically will usually degrade continuously. So some of the formulas we use for that involves E, if you're interested in medicine. Okay, or environmental science, some of that will involve E. The example in your book involves DDT. Pretty harsh pesticide that we discovered was actually harmful to humans in the 70s, so they had to stop using it. But they had already dumped a significant amount in the atmosphere, so what does this say? 10 to the 10th kilograms. What was that, 10 billion kilograms and stuff? Yeah. So lots of applications here. I'm gonna let you pick a problem from 8 to 16.
Just one?
Just one.
You said,
So 1 through 7, then pick one problem from this set. There are lots of applications that if you want to do finance, great. If you want to do medicine, great. It's up to you based on what you want to do with your life. And then this is due Friday. So tomorrow, 11/2 is due. We're kind of trying to play catch up here. That's due Friday. Okay. Basketball teams, you play in the afternoon, right? So you should be here in the morning. Cool. If you have any questions, let me know. I've given you about 25 minutes, so take advantage of that time. And, let me know if you need any help.